In this lesson, we're going to learn about point-slope form. So the previous lesson, you learned about slope-intercept form and where we use the slope and the intercept to make the equation into y equals mx plus b. In this lesson, we're going to use a point on a line. And remember, there's an infinite amount of points, so you just have to pick one point on the line and its slope, and you're going to make an equation. Your essential question is, what information does the point-slope form of a linear equation reveal about a line? So when you get done with this lesson, you should be able to answer that question. Your equation, so this is the first time you looked at it here, is y equals y1, which is the coordinate of the point you picked. So the y coordinate equals the slope, that's the same spot it is in slope-intercept form, times x, that x value, or the x of the variable, minus, and then x1 is the coordinate. So notice x1 and x2, and then your slope. So your points and your slope. I also want to point out before we get too far here is that it is always subtraction, even though here in a little bit you're going to see plus, and we're going to talk about how that affects the point coordinate here, but notice that it is, you're subtracting the y coordinate, and then you're subtracting over here the x coordinate. So your definition is an equation of a linear line that uses any point, x1, y1, and the slope m, and the equation format is y minus y1 equals m times x minus x1. So here's your example. So I told you we'd see one right away with an addition. So I'm just going to put the equation. So it's y minus y1 equals 3, m times x minus x1. So y is y. That is just your variable. That will not change. Now, your x1, notice that says 1 here, but it says an addition. So how do I make the subtraction become an addition problem? Well, the only way that happens is if you subtract, because I know that has to be there, a negative. And mathematically, if you have the opposite of a negative, that turns into addition. So that's why this is a plus sign here. That equals 3 times x minus 4. So you're going to notice in this equation, the slope is 3. So here's the slope. Looks just like it did in the other format. And now the line, or the point, is right here. So here's x1. And the good news is, I don't know how I erased that all, but the good news is, we'll put that back here, is that your x1, now it's not -1, it's a positive one because the x is right there. Because remember I told you it's subtraction. So notice that the x is a 4, and over here, as we already talked about, y1 is a negative because it's minus a -1. Okay, let's look at our example here. So understanding point slope form of a linear equation. So the question is, how can you write the equation of a line using any points on a line? So these are just the steps, and then we'll go through an example. So the first thing you're going to do is find the slope. So remember, you're going to use y, or m equals y2 minus y1 over x2 minus x1. And then you're going to pick one of the points. That's on the line. And I'm going to guess you're going to pick a point that you use to find the slope. And then the last step is just to write the equation in the format. Remember, we're working on point slope, so it's the y minus y1 equals m times x minus x1. All right, so let's go to the example. So I have 5, 8, and 3, -2. So both of these points are on the line. My goal is to make an equation in point slope form that has these 2 points on the line. So first step, it says find the slope. So we'll just call this x1, y1, x2, y2, and we're going to solve. So m equals My y2 is -2 minus my y1 is 8. And I'm going to put that over x2, which was 3, and I'm going to subtract x1, which was 5. So -2 minus 8 is -10. 3 minus 5 is -2. -10 divided by -2 is 5. So my slope that I'm going to use here in a second is 5. Step 2, just pick a point. I'll just pick the first one. So we're going to pick the point 5, 8 because it's already named x1 and x2. Sorry, x1 and y1. And then I'm just going to make the equation. So it's y minus y1, which in this case is 8, equals the slope, which we found in step 1 was 5, times x minus x1, which is 5. And so there is your equation. So let's look at the next question. Why is it helpful to have point-slope form in addition to slope-intercept form that we learned in lesson 2.1? So why do we need to have two forms for the same exact line? So I said it allows you to write an equation for a line without knowing. So if we go back to what we learned in lesson 2.1, we had to know slope, which means that sometimes we had to know the points. And then we also had to know the y-intercept. Now the good news is here, all we have to know is a point and a slope. So what's nice about having point-slope form in addition to slope-intercept form is that we can write an equation without knowing the y-intercept. So to try it. So before I put it down, remember, pause. You can try to do it without listening to my explanation. And then you can look to see if you get it right. And then you can go on to example 2. If you don't get it right, you need to stop, take notes, listen, and comprehend what I'm saying. So the tryout says, describe the steps needed to find the y-intercept of the graph without point slope or using point slope form. So we just talked about you don't have to have point slope form, but can you, if you're in point slope form, find the y-intercept? So I gave you two options here. So the first one is you could just start in y equals mx plus b format, because we're looking for the y-intercept, and so that's the format you'd be using. I just picked the point here, 5, 8. Again, I keep following that same point and remembering from above the slope was 5. So if you know those two things, because this is where you would start from point slope form, you know a point, you know the y-intercept, you know the slope. So you could take and just plug those values in. So 8 is your y coordinate. This 5 is your slope. This x is the x coordinate, and then now we're looking for b. So this is the unknown. So we just solve a linear equation. So 5 times 5 is 25. You'd subtract 25 from both sides, and we have the y-intercept of -17. Your other option, if that one doesn't work for you, you could just go from the point slope equation and plug in one of the point and the slope and then simplify the equation. So I kind of like this one just because you can see it go from up here in point slope form and down here into slope intercept form. So here, remember, this is my point slope form. I'm just going to plug in what we've had before. So we had y minus 8 equals 5 times x minus 5. We're going to distribute to start with, because we got to get rid of the parentheses, and dividing by 5 with the y and the 8 would be not helpful. So 5 times x is 5x. 5 times -5 is the 25. I want y alone because remember I want to get to y equals mx plus b. So I'm going to add 8 to both sides, and I get y equals 5x minus 17. So again, this is into slope-intercept form. So here's that slope. And then here is that y-intercept that we already knew from the previous, but I'm just proving to you that it also works in this form. So again, this one goes from point slope form into y-intercept form. And this one, you just use y-intercept form, plugged in what you knew, and so you could find the slope. Example number 2. How do you write an equation in point slope? Okay, so we practiced this a little bit, so we'll just get practice some more here. So the line has a slope of 1/2, and it passes through the point 3, -2. Write the equation in point slope form. So what's nice about this, step 1 is done for you. Step 1, again, remember, is find the slope. I know the slope. I don't have to go find it. It's 1/2. Step 2, pick a point. So that's, again, not going to be hard because we only have 1 point. So I have to use 3, -2. Step 3, put it into the equation. So we'll move it over here so we can have some room. So y minus y1 equals m times x minus x1. And we're going to plug in what we know. Y stays the variable. Y1, notice I put minus. Y1 here is -2 equals the slope is 1/2 times x is my variable minus my x1, which is 3. And so all we have to simplify is this minus a negative. So my final equation would be y plus 2 equals 1/2 times x minus 3. And there is your equation. Okay. B, okay, we're going to practice again. We're going to put it in slope form, point slope form. We're going to give 2 points. So we're going to have to work a little bit more on this one. They're just not given to us. So step 1, again, find the slope. So slope is y2 minus y1 over x2 minus x1. Here's x1, y1, x2, y2. I'm going to plug in as I go. So y2 is 3. I'm going to subtract it from y1, which is 1. I'll look over here. X2 is 2. And I'm going to subtract x1, which is a -4. So I have 3 minus 1, which is 2. And I have 2 minus a -4, which is 6. And 2 6 equals 1/3. So my slope, again, right here, so we don't forget, maybe circle it, is 1/3. Step 2, pick a point. I don't care. Any of the points, I'll just pick the first one since it's right there. I just kind of like to pick the first one because it's already named x1, y1, but it doesn't matter. So step 3 is to plug it in. So I can write the equation again. Y minus y1 equals m times x minus x1. As many times I've said that, you will get really used to saying it out loud. So y minus, notice this is y1, so y minus 1 equals your slope 1/3 times x minus, and x1 is a -4. So y minus 1 equals 1/3. We're going to simplify x minus a -4. So that means it's +4. So that's the equation if you pick the point -4, 1. If you pick the point 3, 2, we'll just go through that. And they're not going to end up being the same equation, but I can promise you they produce the same line. It's just because you picked 2 different points. So y minus, come back over here, y1, which is 3, equals your slope, which remember is the same slope as before, so 1/3 times x, and x1, we're using this one, x1 is 2, and then you don't have to simplify because there isn't a double negative. So you can write it with the first point and get this equation, or you can write it with the second point and get this equation. So stop, do the try it. See if you get it right. You can forward it through and see if it's the right answer. If it's not the right answer, back it up and make sure you're able to figure it both out. So the blue, I have two of them because there'd be two equations depending on which point you pick. So the first one is find the slope. You use that same equation that we keep using, y2 minus y1 over x2 minus x1. So you can see that I plugged in 3 minus a -1, -3 minus 2. You get 4 over -5, which equals -4/5. So that is my slope that I'm going to use. And then step 2, you're going to pick that point. Okay, so I picked that point right here. I should say this is step 2 and 3. So I picked the point, the first one, I'm just going to use the first one is 2, -1, and then I'm going to plug that into the equation. So y minus, my y1 is -1, equals -4/5 times x minus, and x1 is 2. So just simplify it. Y minus a -1 is y plus 1 equals -4/5 times x minus 2. So here's one equation. And then I'm going to do it with using this equation in case you like the second one better. So don't have to find the slope because it's the same slope as before. So I'm not going to redo step 1. I'm just going to go right into step 2 and 3 here. So this is the point I picked for step 2. Here's my step 3. So I'm just going to plug in what I know here. So it's y minus y1 is 3 equals, oh, I forgot to put my slope in there. Let me fix that. My slope from above was -4/5 times x minus, and this time it's a -3. So when I rewrite it, it'll be y minus 3, that doesn't change, and then -4/5 times x, and then we're going to say plus 3 because minus a negative is an addition. Example number 3. This time we're going to sketch. So we've been making the equations. Now we know the equations. We're going to put it on the graph. I'll put my 2 here. So step 1 is to identify a point on the line to use for the equation. I'm sorry, a point from the equation and plot it. Okay, so if we go up here, we should be able to pick out our points here. So remember, this is y minus y1, and over here, this is x minus x1. So our x value is right here. Now notice it's a positive, so that means that it had to start with minus a negative. So my x value is actually -1, because minus and negative turns into that plus. And over here, your y1 is just 3, because that minus stays with y minus and then the y coordinate. So your point is at -1, 3. So go to -1 and up to 3. And there is your point. So that is the point from the equation. Step 2 is to use the slope from the equation to find the second point. Sorry, second point, not second plot. All right, so my slope, remember, I'm not going to use the equation, I'm just going to talk about, remember, it's vertical change, which is why it's your y's, because the y's go up and down, or I write it like the change of the y, over your horizontal change, which remember is the change of the x's, because that changes horizontally, changes on the x-axis, back and forth, back and forth. Now, your slope from coming up here is -2/3. So -2, remember that goes with the numerator, thirds. So this is a vertical change of -2, which means you're going down 2 units. This is a horizontal change of 3, so that's positive, so you're going right 3 units. So again, we're going to come up here. It says a vertical change of -2, which means we go down 2, 1, 2, and a horizontal change of 3. So we're going to go right 3, 1, 2, 3. So your second point should be here at 2, 1. And then you take your straight edge or your ruler. Let's see if I can make this work a little bit better. If it lets me. Make your straight edge here. There it goes through. I'll have to make it longer on this side. Yours will look better. And don't forget to put your little arrows at the end. And there is your graph from the equation y minus 3 equals -2/3 times x plus 1. Stop the video, try it on your own. Fast forward through my explanation if you don't need it. Make sure you have the graph right. If you don't have the graph right, rewind it, watch my explanation, and learn from it. So here's the tryout. It says to sketch the graph of y plus 2 equals 1/2 times x minus 3. Too many x's and y's. So your first step is to plot the point, which means you got to go find the point. So if you notice, here is your x. Okay, so it's just 3 because x minus goes with the original equation. So it's just 3. Over here, it's a positive, which means it had to be a double negative. So minus, because those go, y minus goes together, and then a -2 to make that positive. So notice that y value is -2. So I went over and plotted 3, -2. And then I'm going to use the slope. So in this case, the slope is 1/2. So remember, vertical change over horizontal change, or you can start writing it like this if you want to. Change of the y over change of the x, because this is your y vertically, this is your x horizontally. So this is the change of the y over change of the x. So it's 1 is a vertical change, which means it's positive, which means you're going up 1 unit, and then the 2 horizontal change means you're going to the right 2. So here's your first point we had, go up 1 and over 2. Now, if you don't think that's enough, of course, you can make more points and keep doing the same slope over and over, up 1 over 2. If you get enough points, last step is just to draw the line. The final example, which is always your problem solving. So the question is, an event facility has a banquet hall that can hold up to 250 people. The price for a party includes both the cost of the room rental plus the cost of the meal for each guest. Marissa is planning an event for 75 people and has budgeted $1,200 for the party. Will that be enough? So when we look at this, we can notice that we have total cost over here. We have number of guests, and we're going to apply it to the point slope form. So formulate, first of all, what are we doing? We got to come up with a way to use point slope form so that we can represent the number of guests and the total cost. So formulate, you're going to use point slope form here. To see if we have enough money. So if we're looking for point slope form, the first thing we need to do in step 1 here, so we'll start solving, is, hopefully you're saying in your head, find the slope. So we need to pick 2 points here, and it doesn't really matter which 2 we pick. We'll just go with the first 2. So x is 50, and it looks like y is 725. So we have x is 50. I'll erase that so it looks better. X is 50, and it looks the y then, so 50 50 guests come, 725. Second one here, if 100 guests come, double that, it's going to cost us 1,325. So you can tell it's not linear because it didn't go up at the same rate. So find your slope. So x1, y1, x2, y2. So it's y2 minus y1 over x2 over x1. So plug in what we know. Y2 is 1,325. We're going to subtract that from y1, which is 725. And we're going to put that over x2, which is 100. And we're going to subtract x1, which is 50. So 1,325 minus 75 is 600. And 100 minus 50 is 50. So 600 divided by 50 goes in 12. So just because it's a storyline, let's think about what 12 means. 12 would be the cost per meal. Okay. Now, next step is because our goal is to find out if we have enough money and we know how many people are coming. So we're going to take this and put it in slope-intercept form so that we got to go to that step 2. So pick a point. Let's pick point. Let's just pick the original or the first point like I've been doing. So 5, 725, and we're going to make the equation. So y minus y1, which is 725 in this case, equals your slope, which we found out was 12, times x minus x1, which is 50. Now we're going to use this equation because that's our goal, is to use the equation to find out if we have enough money. So how many guests do we know that are coming? 75. So we're going to take 75 because that is our x. Remember up here, this is the x-axis, and that's the number of guests. So we're going to put that in the x variable. So we're going to go y minus 725 equals 12 times, this time we're going to put 75 in there. Whoops. Back up that. 75. And we're going to subtract that 50. So y equals 725. So if you take 75 minus 50 is 25, and 25 times 12 is 300. We're going to add 725 to both sides to get y by itself here, because remember y equals, and maybe I should put that in the formula, or the formula. X, remember, is the number of guests, and y is the total cost, and that's what we're looking for. We were wondering if we have these 75 guests, do we have enough saved up, or does Marissa? So y, which is the total cost, equals 1,025. So going back to the question, if she has these 75 people come, does she have enough money? So if I read the small print here, it says Marissa's planning to have that 75. She has budgeted 1,200 for the party. Will that be enough? So when we plugged in 75 in for x, we got the y value of 1,025. So the answer is yes. Marissa has budgeted enough money. You could say the cost for 75 people, or I should call them guests, would be 1,025, and her budget was 1,200. So all is good. She can invite that many guests, and she's budgeted for it. The try it, erase that a little bit, says rewrite the point slope form. So this is the equation we came up with into slope intercept form. I kind of did that in problem 1. So if you want to stop the video and try it yourself. If you're not sure about it, just follow along here. So here's my point slope form. This is where I'm going to start. My goal is to get down to my slope intercept form. so I can look at the y-intercept. So we're going to take 12 times x, which is 12x, 12 times the negative 50, which back to negative 600. I want y equals mx plus b, so I'm going to add some 725 from both sides, and I'm going to get y equals, so this will cross out, 12x, and the negative 600 plus 725 is a positive 125. So the question at the beginning was, what is the y-intercept? We found the y-intercept. It's 125. The question now is, because if you go back to this graph, the question is if they were to graph this into a line here, it doesn't, well, mine doesn't look very good, but it doesn't cross the y-axis at 0, so the question is, where does it cross at? Well, now we know the answer. It crosses at 125.0125. What does that represent? And down here I said it represents the cost of the room rental. I hope that was helpful. Again, if you have questions, email me, or I have Google Meet going all day long. So you just jump on, get your question answered, and then jump off. Have a great day.